Hey, I want to talk about one of my favourite talks at Laracon US this year, which I was really pleased to be able to attend in person. It was Jake Bennett's awesome talk on state machines, which I'm rewatching right here. If you haven't seen it, I recommend that you go and watch it. You don't have to watch it right now. I'll put the link in the description and you can go and look at it when you've got time. It's less than 30 minutes. It's a really slick presentation. It's Jake's first talk at Laracon and he absolutely smashes it. What really got me though is state machines are something that I've not really ever looked into. I've used them, sure, but I don't really understand them. And Jake opened that box for me and unlocked a part of my brain. In fact, in a recent client project, I was using a really powerful e-commerce package called Silius, which exposed me to another package called winzou state machine. I'll put the link to that in the notes as well. Having not really understood state machines for a long time, I've been doing software engineering for 20 years. So can I even call myself a software engineer anymore? I don't know. But I'm kind of in the group of devs that Jake calls those who are using an event action paradigm. But after his talk, I'm fully bought into shifting towards the event state action paradigm. And I think it's really important to just hone in on a couple of the points that Jake makes as to why this is so powerful. First of all, you can see this controller that he's got on his screen. And it's very, very simple. To give you some context, this pay invoice controller is just a single invocable control, single method controller. And all he's doing is saying the request that's come in is essentially saying to the invoice that's being targeted, this invoice should be paid. Now, however that happens in this system, the behavior might be different. And that's what he's just described when we get to this point. And he's basically shown that this single controller and this single state transition, the pay method, can be used to describe what should happen when we need to pay this invoice, regardless of what state it's in. And it's fantastic because it reduces multiple lines of code in a controller and potentially really complex if statement logic into different classes that represent the state of the invoice and what should happen when this event occurs. And so the context is all wrapped up in another class which represents the current state of the invoice. And it's fantastic. Let's watch what he says next.
So this is awesome as a developer. I can unload all of that cognitive load that I need to keep track of in my head to figure out, can I do this? What should happen? No longer do I have to have conditionals about what state I'm currently in. The class just handles it. And so this is a transition, this is a paradigm shift from event action. This is what we typically do as developers. An event is coming in. What should I do? Right? We describe, we say in the controller, here's what we should do. And instead of saying event action, we say event, delegate that event to the state machine, and now the state machine is responsible for taking action. So we get to program this up front, decide how our application should behave up front, and then we simply delegate those events to the state machine, and the state machine enforces that behavior. So this is awesome. This is huge. I've been so excited to share this with you guys. Let's talk about the benefits real quick.
Okay, I'm just going to pause there because I think it's really important. What he said is that this is a paradigm shift, and it is. If you've not been creating state machines yourself, this is a major change. And this is why I think this talk is so good, because he exposes, in probably less than 20 minutes, he exposes you to the concept of a state machine very, very well, and how to write the code to do it. And he's going to show a little bit more in a second why that's important to even contemplate doing it that way. But there's one thing that we typically do, and something that I've experienced in kind of doing a bit more of this recently. When we see somebody talk about something and we get excited about it, we start to think, oh, like this is the hammer that I should use for everything. And whilst it can be done. You could devolve every part of your system down to some kind of state machine. I want to actually recommend that you don't do that. I think it's really important in some very specific cases. And the talk highlights a perfect example of that case. I'm doing something similar with state machines. That's why I want to go into when to use a state machine and when not to use a state machine. See, there's absolutely nothing wrong with that event action paradigm. As Jake said, we've been doing that for years. So we can continue to do that. There's nothing wrong with that. But the event state action paradigm really shines when you've got an object or a piece of business logic that's quite complex, and there are interdependencies internally and maybe externally on what is the state, what makes up the current state of that thing, and what transitions it can and cannot do. And that's why a state machine is so powerful, because it helps us to encode in very simple logic, as you'll see when you watch the talk, very complex rules around both of those things. What is the state and what can the transitions actually be? And that's why it's not going to be a great practice to go through and create state machines for every part of your system, because those strict rules may not apply to every single thing in your application. So what kind of things will it apply to? Well, the example that Jake uses is of an invoice that's getting paid, and that invoice might be in a few states. It might be already paid, it might be unpaid, it might be that it's been kind of cancelled off and then somebody tries to pay. And there's different behavior that needs to happen in those different circumstances. The way that I'm using a state machine at the moment is in a very similar system, but it's in a payment process. So whilst it's not dealing with an invoice specifically, it's just dealing with this concept of a payment. In practice, it's probably very similar to what Jake's done. And that's why I really appreciate this talk, because it was very practical for something that I'm working on right now. And it's come in really, really useful because it's framed how I think about the problem, but also highlighted something to me. Not just that this is an appropriate solution to the problem that I'm having, where if a payment has been made, it shouldn't be able to be made again, for example, or if a payment has been cancelled or it's failed, that the state transitions that should be available and should not be available to that thing are more in need of more rigor than I can do with a few if statements and without it becoming a real soup of logic, which I don't want. So it's been great to identify that. But the other thing that it's helped me to realize is that I actually do just need to model my system visually more often than I do. And what I really picked up by doing the state machine work as I was re-watching this talk and thinking about the problem in my own application, I was doodling exactly a state diagram already. So I was probably doing some of this without maybe the rigor of a proper state diagram. And what it's enforced me to do is actually go and do a proper state diagram. And I think it's so powerful that you've now got this piece of documentation that you can use. This is one of the benefits that Jake talks about now, so let's let him say it because he's going to say it much better than I can.
Quick. So these are the problems we originally started out with. Difficult to determine what rules apply when. Thanks to our state diagram, that's not really a problem. We've got really good documentation on how we should go from one state to the other. And if we want to know how we go from one to the next, we just have to go look at those classes. Just a simple set of classes. No package needed. Very simple pattern.
So there he said our diagram has basically become documentation, and the code is also documentation. That's an important point too. One thing he said there is that there's no package needed. And this is interesting because there are actually quite a few packages that try to solve the state machine problem. The winzou package that I was talking about earlier is one of them. Even Symfony has this concept of workflows and a state machine management and configuration that you can use. I'm not sure what version that came in, but it's very cool that these things are packaged up in an abstract way that you can use something that's already going. But I think it's really important to try and embrace state machines. It's helpful to just follow what Jake's done. I've experienced that just recently. In implementing my own state machine, I found I really deeply understand the concept much more. I don't know whether that translates to me being able to talk about it very well, but I feel like in my head it makes a lot more sense. Keeping it simple and writing your own state machine means that you understand that part of the code much more deeply. And I think that if you're using another package for yet another relatively straightforward problem space, you probably end up in more hot water than it's worth. Let's see what Jake has to say.
We have this duplication of logic every place that we want to update the invoice. No longer do we have that. All we have to do is delegate the action to our state machine, and it'll take care of it. If we wanted to mark invoices as paid from a command line, no big deal. Invoice, state, pay event. Should it be allowed? Should it not? Throw an exception? Don't care.
That's another really important point. The state machine logic ends up looking very, very straightforward. And by that I mean not the logic that we saw in our controller, where the state machine was being used, but the actual logic that goes into each one of the state classes is straightforward. It's super clear because we've narrowed down our scope of context to just one state. And that is also something that I think we need to take away from this talk, which is not explicitly stated, pun intended. You can get down to that one context. When you're dealing with event action, as your system grows, it just grows in complexity. But if you break it down to individual states in this state diagram, you codify those as state classes. What you end up with is these very small pieces of clear, single responsibility pieces of code. And that's super powerful. Obviously, it makes it a lot easier to digest what's going on, what should happen when a thing is in a certain state. But it also helps us to think carefully about what our state machine should be doing and how it should look. Let's say it's a payment and there's a paid state and a failed state. So maybe we should call them success and failure. Both of those could be considered a completed state. So which should they be? Is it completed? Is it failed? Is it paid? This might seem really obvious, but we want our object, the payment in this case, to be in one state. It should really only be in one state at a time. So a state called completed, which could imply that it's either successful or that it's failed, is not really going to cut it. And that implies different behaviors, which means different state transitions, which means our logic in our state machine may need to change. I think just thinking about the fact of having a single class being responsible for a single state, that's been the biggest shift for me mentally into why state machines are such a powerful tool in these complex scenarios. Anyway, enough of me. Let's listen further to what Jake has to say.
And because the code only ever grows in complexity, now we have a sustainable way to add new actions to our existing code simply using classes and methods. Nothing special. Everybody can figure this out.
And he's right. The code complexity stays very minimal. If we wanted to add a new state, let's say a payment can be refunded, it's not a case of going into an existing class and trying to figure out all of the logic and how it should sit and how it should flow. We can simply say, what state am I in? What transition should I be able to achieve when I'm in this state? And so if you take that example of a payment that has been paid and can be refunded, there's very minimal changes that actually need to be made to our whole system. We might want to say that there is a transition available to the system called refund, and all of the other states except paid can't use that transition. So in the way that Jake implemented this, we could say those all return an exception, and then it's only in the paid state class that we add the logic for the refund. And the refund can do whatever we want it to do. It can just go to call the payment gateway and say initiate the refund, and update the database. It can do all of the things that we need it to do when a refund occurs. And that way it's like nicely encapsulated in just that tiny class that just does those few things. So our paid state can have a refund method that transitions the state of, let's say it's at this payment model, to refunded. And then when we call the state of the model, again, when we ask for the state machine, we'll have a refunded state class come back if we've defined it. It's really, really simple. It's almost too simple. And I think it's changed my mind. It's changed so much about how I'm thinking about the systems that I'm building that I do want to reach for it more often. But as I was saying earlier, I think it's really important that we pick and choose carefully the places where this is most appropriate. That's it. I hope you enjoy the whole talk. Give it a watch, give it a rewatch. I'm sure it'll come, if you've not used state machines before, I'm sure it will come in really, really handy to have this as a reference. Thanks for watching me go through a little bit of a talk that I really enjoyed from Laracon this year. If you enjoyed this video, I'd love it if you could like, subscribe, share, do all those lovely things that help me realize that this is actually useful content and that you enjoy it. Have a great rest of your day. Ciao for now.